Last lesson for the week. All we're doing here that's different today is we're throwing in the shifting of the vertex, or the center. I guess that should say center instead. Pretend like it said center. So if the center shifts, what you're going to see in the equation is you're going to see h and k. So all you got to make sure, still the rule is those are in parentheses. Anything in parentheses is in opposite land. You have to think opposite when you're writing the center. And then all of our movements are going to happen from the center. So when we move the square root of the denominator in the direction of the numerator, we're still going to be doing that, but we're going to do that from the center. C, we find the same way, but that is also going to move from the center. So every movement that we make will now be moved from the center to get to where we're trying to go. So we jump in right away. The center, we're going to get by looking at those h and k numbers. The center for this particular ellipse is going to be over 1, down -2. So I'm going to go over 1, down -2. That's going to be my new starting point. Every movement's going to happen from there. Then I'm still doing the square root of the denominator, which is 3 in the direction of the numerator. X is in the numerator, so this means I'm going left, right, 3. 1, 2, 3. 1, 2, 3. And then same thing with the other denominator. Square root of 25 is 5, but that one has y on top, so that means I'm going up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we'll go ahead and draw the ellipse through those points. And then here's what's new with these, is the foci. Still the same formula. C squared equals a squared minus b squared. So that's going to be c squared equals 25 minus 9. C squared equals 16. And take the square root. We get c is equal to 4. But that has to now be added on from the center. That's the movement we're going to add on to the center. We have to pay attention to what's in control. So if I looked back over here, it was the y that had the bigger number. So that tells me y is in control, which means that 4 is going to get added and subtracted onto the y coordinate of the center. So it's going to be 1, -2 plus 4, and the other foci point will be 1, -2 minus 4. Since it's a whole number, we will work the math out here. This is going to be 1, +2, and the other point will be 1, -6. So those are the foci, 1, 2, and 1, -6. And if I graph those, over 1 up 2, over 1 down -6, those end up inside of the ellipse on the vertical axis, same distance from the center, same distance from the foci. So that's how you can check to make sure that they are correct. Let's try another one. In this one, the center is -3, 0. So we're over -3 up 0. And then we're going to move the square root of the denominator, which is 4, in the direction of the numerator that has x. So that's our left-right changer. Left, 4, right, 4. And then square root of the denominator is 2 in the direction of the numerator. Y is in the numerator, so we're going to go up and down 2. And we can draw our ellipse. And then to find the foci, c squared equals a squared minus b squared. That's c squared equals 16 minus 4. C squared equals 12. And take the square root. That's 2 radical 3. So this one is not as nice to add on. I've got to pay attention to what's in control for this particular problem. Just by graphing it and looking at the bigger number, I know that x is in control. So that 2 radical 3 is going to get added on to the 3, and it's going to be subtracted from the 3 as well. And those are officially what I would want you to write as the foci. I don't want you to simplify it down. I want it with the radical in it because that's the exact value of the foci. But what you could do is you can turn those into decimals to help you graph them. So if you type them in your calculator, this guy ends up being 0.46, this guy ends up being negative 6.46. That's just to help you graph it. So we're over 0.46 up 0, that's right there. And over negative 6.46 up 0, that would be right there. So again, they're on the major axis, and they're the same distance from the center and from the foci. And number 9 just throws in the twist that we saw yesterday. It doesn't equal 1. That's why we don't see any of the fractions right now. We need to make sure that it equals 1 first. So we would have to divide by 9 first to make it equal 1. And we get x squared, x minus 2 squared over 9, plus y plus 3 squared, and then I'm going to write this over 1. I'm going to keep the 1 there so I know what I'm moving, equal to 1. If you ever have something that's not a fraction, you have to make it a fraction so you know what your movement's going to be. And then the center is going to be 2 comma negative 3. So I'm going to go over 2, down negative 3. That's my center. And then I'm moving the square root of the denominator in the direction of the numerator. So the square root of 9 is 3. I'm moving in the x direction. Right 3, left 3. And then the square root of 1 is just 1. So it's just going to be up 1, down 1. And it's going to be this little teeny tiny ellipse right here. And then to find the foci, we're going to do c squared equals a minus b, 9 minus 1, a squared minus b squared. We get 8, and take the square root. We get 2 radical 2. And then you have to think about where to add that onto. To find the foci, you need to make sure you're adding it onto what's in control. In this one, x is in control. So that's going to get added onto the 2. So it's going to be 2 plus 2 radical 2, comma negative 3. The y will stay exactly the same. And then it'll be 2 minus 2 radical 2, comma negative 3. And just to help you graph it, if you type those in the calculator, this guy's 4.8. This guy's negative 0.8. So we're over negative 0.8, down negative 3, and over 4.8, down negative 3. They end up where they're supposed to. That's all I'm checking when I graph them, to make sure they end up where they're supposed to. It just double checks my work. That's all for today. There is a problem for you guys to try on ClassKick, and I'll be checking in on that. And then you have some problems to do for homework just to make sure you're understanding the shifting part that we talked about today. Okay? Have a good rest of your day.